Okay, let's take a look at a few examples of calculating derivatives of inverse trig functions. And to help us with that, I have the 6 derivative rules rewritten here. So let's start first with the derivative of arctangent of 3x. So if we go to our derivative rule for arctangent of u, that would be this one here. So we have that its derivative is going to be u prime over 1 plus u squared. So let's identify, in this case, what our u would be. We want to take the derivative of arctangent of 3x, so that means that our u is 3x, and so u prime would just be 3. So our derivative, f prime of x, then, is again u prime, so that's just 3, over 1 plus u squared. So 1 plus 3x squared would be 9x squared. Okay, so pretty straightforward in that case. We just have 3 over 1 plus 9x squared, not too bad so far. Let's take a look at another example. Suppose g of x was arcsecant of e to the 2x. All right, so let's go up and look at our rule for arcsecant. So that's this rule here. We have that the derivative of arcsecant of u is u prime over the absolute value of u times square root u squared minus 1. Okay. Maybe to make life easier, I'll jot that down here. So we've got u prime over absolute value of u times square root u squared minus 1. Okay, so for this example then, our u is going to be e to the 2x, so u prime would be 2e to the 2x. So our derivative, g prime of x, in this case, is u prime 2e to the 2x over, okay, so we have absolute value of u. So that would be the absolute value of e to the 2x. But if you think about the expression e to the 2x, e is a positive number, and if we're raising it to any power, then it's just going to be, e multiplied to itself some number of times. So it's a positive times a positive some number of times. That is always going to be a positive value. And that means that the absolute value bars here are redundant. We don't have to write them. We can just write e to the 2x. And then we have times the square root of u squared, so e to the 2x squared would be e to the 4x minus 1. And if you want to note off to the side when we take e to the 2x and square it, remember powers raised to powers get multiplied together, and that's where I'm getting e to the 4x from. Okay, so there's our derivative there. Again, not too bad. Oh, actually, sorry, I shouldn't put a box around this yet. Now we have a common factor of e to the 2x in the numerator and denominator, right? These can cancel out, leaving us square root e to the 4x minus 1. I suppose you should also ask yourself if the if the denominator could possibly simplified in some way that would get rid of the root, and if that radicand was a perfect square, then it could. E to the 4x minus 1 actually is factorable, but it would follow a difference of squares factorization, right? It would be e to the 2x plus 1, e to the 2x minus 1. So it wouldn't be possible for us to eliminate the root there. Okay, so let's look at a slightly more complicated example. Suppose h of x is arcsine of x plus x times square root 1 minus x squared. All right, so let's go back and look at our formula for arcsine. That's going to be all the way at the top. And we have the derivative of arcsine of u is u prime over 1 minus u squared. Okay, so I'll write that down here. We've got u prime over 1 minus u squared within a square root. Okay, so in this case, we have arcsine x, so our u is just x, and so u prime is just 1. So that first term of our derivative, h prime of x, that's going to be 1 for u prime over square root 1 minus x squared. All right, so the second term here, x times square root 1 minus x squared, that's a good bit of review here because this term is going to require the product rule to differentiate, and then within that product rule, we're going to have a couple of chain rules actually. So let's see here. So per the product rule, we're going to take the first factor of x times the derivative of the second factor. So that second factor of 1 minus x squared to the 1/2, right? That's how we could rewrite that square root. That's going to have a derivative of 1/2 times 1 minus x squared to the negative 1/2, right? We bring down that exponent, reduce the power by 1. But then we need to multiply that by the derivative of what's inside those parentheses per the chain rule. So that would give us an extra factor of negative 2x, the derivative of 1 minus x squared. And so those, oops, sorry, not sure what happened there. All right, let's go back here. Sorry about that. So those factors of 2 are going to cancel, and that would give us a negative 2. Oh, sorry, we got rid of the 2 rather. Negative x times 1 minus x squared to the negative 1/2, which is the same thing as negative x over 1 minus x squared to the 1/2. Okay, so we had the first factor of x now times the derivative of the second factor, which we now know is negative x, over 1 minus x squared to the 1/2. I'll go ahead and rewrite that with the square root notation, so square root 1 minus x squared. Okay, so it's first times the derivative of the second plus the second, which is square root 1 minus x squared, times the derivative of the first, which is just 1. Okay, so again, that's a good reviewy sort of derivative. Kind of get back into the habit of when you have trickier factors like square root 1 minus x squared, maybe we pull those off to the side and differentiate them separately like we did over here, and then plug them back into our derivative formula. And again, just recall product rule, first factor times the derivative of the second plus the second times the derivative of the first. And that first factor had a derivative of 1. Some people write that in the other order, right? Second times derivative of the first plus first times derivative of the second. Same exact thing, terms just in the opposite order. All right, so let's look at how we'd simplify this thing. So if we look at the first two terms, they both have denominators of square root 1 minus x squared, so I can go ahead and combine them. The first numerator was 1. Second numerator is x times negative x, so that would be negative x squared. And then we've got plus square root 1 minus x squared. Okay, so we could look to combine these as a single fraction by taking the second term, multiplying the top and the bottom by square root 1 minus x squared and combining them from there. Or if we keep in mind that that numerator of the first term is equivalent to square root 1 minus x squared squared, right? We can take the square root and then square that numerator. We then see that that would cancel the denominator and leave us with square root 1 minus x squared. So I've got square root 1 minus x squared plus square root 1 minus x squared, and that would be 2 times the square root of 1 minus x squared. And there's our simplified derivative for that one.